Okay.
Okay. So hopefully, Bonnie, you're doing first 6 weeks online, right?
Yes.
Okay, so hopefully this is how I can do the Zoom calls. Because I think you could see this better than I was doing it before. I just got this software downloaded on my computer, so that's why I hadn't done it before. While I'm talking, if y'all want to check your answers here on those guys on this front page. So hopefully this is how I can do it, because then also the projector works for in class, so I can Zoom call during class, or it records, hopefully, we're gonna see, and you can also watch it on your own time. So it depends. If you want to join in a class period, you can join in a class period, or you can just watch video whenever you want. So we'll see how it goes. But this way you can see it better than when I was trying to just video my screen in the classroom. It was hard to see. And I can zoom and stuff. I can do stuff, whereas before I couldn't do all that. All right, any questions on those three or those guys?
No, ma'am.
No.
Next page. So, John, you asked right before you left, they're all going to be horizontal lines. Yes, because they're all just numbers. None of them have an X with them. So you should have had 3 horizontal lines, solid dot here, open dot here, solid dot here, open dot here. Is that what y'all got?
Yes.
Sweet. Yay. Okay. Any questions about any of that?
No.
All right, so we're going to now move on. Come on, let me get my pen. To factoring, yay, factoring, hello, factoring. Okay. All right, this first section here is just GCF, divide out the common factor. So no matter what kind of factoring, and this always gets people, you have to pull the GCF out first. So you have to look, see, can I divide those numbers by anything? Is there a number that's in common? And what can you divide 24 and 8 both by? It's got to be the highest number. So like you can divide them both by 2, it's true, but you can go even higher than 2. You can divide them both by 4, that's true, but you can even go higher than 4. So I think they both are divisible by 8. And when you divide 24 by 8, you get 3. And we didn't do anything with the X, so the X stays in there. And when you divide 8 by 8, you get 1. So make sure you do have the holding spot of 1 and you don't leave it blank because you're dividing, not subtracting. When I say take out, I'm not meaning subtract, I'm meaning divide. So you're dividing out a number. If you were to go back and multiply, you should end up with your original answer. All right, so I'm gonna whip through some of these. I'm gonna skip number 2. Y'all can do that one for practice. Number 3, they both can be divisible by 3. You can divide both those numbers by 3, nothing higher than 3 though. And they also both have an X with them. So we can take a 3X out. That's your whole GCF. Because they both can be divided by 3 and they both have an X. So 3 divided by 3 is 1. If you want to put the 1 there, you can. You don't need to though, because here we have an X squared. And when you take an X from an X squared, you got to remember your exponent rules. So exponents you subtract. So we have 2 X's here. We're going to take 1 and put it on the outside, which means we're going to have 1 X left over on the inside. So exponent rules are different than your coefficients. Your coefficients are just whole numbers, so you're just dividing that whole number out. When you take the coefficients, or when you take the variables out, you're paying attention to the exponents. So the rules are different. And then minus 6 divided by 3 is 2. And because you took that X out, you don't have to do anything with that X right there, and it stays there. And then, like I said, because you have the X holding that spot, you don't actually need that 1. And you probably will see it without a 1. It's not wrong if you put it, but you probably don't need it. So either one of those are good. All right, so that's GCF. The next kind of factoring, and then stop me if you get stuck. Next kind of factoring, difference of two squares. Difference of two squares. You need to be able to recognize that it's a difference of two squares. And what I mean by that is you have to recognize that this is a square and your second number is one of the perfect squares. And when I'm talking about perfect squares, I don't know if you have to write them up here at the top. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64, and so on and so forth. You could keep going if you want. But you got to be able to recognize those numbers. Or you got to be able to recognize those difference of squares. So I'm saying, oh, square, 100, I know that's a perfect square, and it has to be a subtraction sign. That's where the difference comes in. If it is an addition sign, you can't do anything. So it's got to be a subtraction sign. So we can write this as x plus and x minus, and it's an x because x times x is x squared. And then the second number is going to be the number that multiplies itself that gets 100. So 10 times 10. 10 times 10 is 100. X times x is x squared. And then what will happen if you FOIL this back out, your positive 10x and your negative 10x will end up canceling each other. And so you'll just have the first and the last terms. So x times x, which is x squared, 10 times 10, which is 100. All right, go to 7, example 7. So same thing, it looks a little different because there's a number here in front, but that's okay. Everything is still a square. 36 is a square, x is being squared, 1 is a square, and you're having a subtraction sign. So it's still a difference of squares. For the first term, remember that's coming from this first term here. So the number times itself that equals 36 is going to be 6.
Oh,
But it's not just 36. It's 36x squared. So these 6's also need to have the x with them. So when you were to multiply it, 6x times 6x, you get 36x squared. That first term should end up being that guy. And then your second guy is going to be what times what gives you 1, which is just 1.
1.
And then 1 is plus, 1 is minus. It doesn't matter which one's plus, which one's minus. You just got to make 1 plus, 1 minus. All right, so that's difference of squares. Are we good with difference of squares?
Yes.
Okay, cool. X method. All right, X method is where you have to think what multiplies to give you 18, but subtracts to give you 3. All right, so you kind of read it backwards. And I think most teachers teach it here with the X, where you put negative 18 on top. We want to multiply to get negative 18. And we want to get 3 on the bottom. So we're going to come up with two numbers that multiply to get this number, and then add up to get the bottom number. So you kind of got to know your multiplication tables here. I know 6 and 3, because 6 minus 3 is 3. 6 times 3 is 18, but one of them is going to have a negative. Only one of them, because when you multiply, you want to get a negative number. Does that make sense? Hopefully.
Yes.
Okay. And because we are going to, when we add them up, we get a positive number, this 3 here is going to be negative. 6 minus 3 is a positive 3. And 6 times negative 3 is negative 18. If we did it opposite, if the 6 was negative, that would be a negative 3 down here, and it would be wrong. So make sure that everything matches. 6 minus 3 is 3. 6 times negative 3 is negative 18. And then you can throw it into your factors, x plus 6, x minus 3. Okay. I think I'm going to do all three of these. So I want to multiply to get positive 64. I want to add up to get negative 16. All right, so when you are multiplying and getting a positive number, your signs have to be the same. These two signs have to be the same. They're either both going to be positive or they're both going to be negative, because a double negative turns to a positive number and two positives are a positive number when you multiply. They can't be different though, because if they were different, this would be a negative number when you multiply. So that's kind of a good rule of thumb. I know these signs are going to be the same, and we want to multiply and get 64, add to get 16. So I'm thinking 8 and 8. And because I want to add and get a negative 16, these guys are going to both be negative. Double negative turns to a positive. And when you add it up, it keeps the negative sign. So x minus 8, x minus 8. And this guy here is special. You can write it like this. There's nothing wrong with this. I would give you credit. The AP test would give you credit. But you also could write it a different way because they're the same thing. You can also write x minus 8 squared. So either one, it doesn't matter. Just know you might see it both ways. Ready. 10 on top, 7 on bottom, and we want to multiply to get 10, add to get 7. So this one's pretty easy. What are the factors?
5 and 2.
5 and 2. So x plus 5, x plus 2. All right, very good. Hopefully you remember the X method and how to do those problems. The one you probably are a little rusty on, or most people are rusty on, is the slide and divide bottoms up method. And you know you have to do this method when there's, you see this number in front of the squared term? When there is a number in front of the squared term and it is not a GCF, right? I cannot divide a 2 out. So it's not a GCF. There's a number here in front. We're going to do something called slide and divide. So first we are going to slide, and we're going to slide 2 times 7. So 2 times 7 is 14. And that's the number that's going to go on top. Middle number here, 15, is still going to go on the bottom. All right, so that's the slide part. And then you're going to solve it the same way. What multiplies to give you 14 adds to give you 15. 1 and 14. And we're still going to put it in our factors. X plus 1, x plus 14. All right, so that's all the same. So that takes care of the slide. And then the last step is to divide. All right, and that's what people forget to do, is they forget the divide part. So don't forget, slide and divide. And you are always going to divide by this front number here. So in my case, it's a 2. So I'm going to divide both of these numbers by 2. All right. Now, does 1 divide by 2 nicely? No, you end up with like a decimal. And that's where the bottoms up comes in. So if it doesn't divide nicely, you can't reduce it or anything. You take whatever is on bottom and you put it in front of the X. Still inside the parentheses, still inside that factor, it just goes in front of the X. And so now this factor is 2x plus 1. For my other factor, 14 divided by 2 is
7.
7. And so that one will turn into a 7. And then that would be your final answer. So slide, work it out the same way you do the other ones, and then divide, reduce, bottoms up. Kind of, so a couple extra steps, still not anything too difficult, but definitely a couple extra ones. All right, so I'm gonna do this one here. All right, so I'm noticing there's a number in front. I also know it's not a GCF because you can't divide a 2 out. So I'm going to slide 2 times 3. And it gives me 6. And negative 6, because 2 times negative 3. And then negative 5 goes on the bottom. All right, so I want to multiply and get a negative number. So these signs have to be different. All right, they have to be different. Now this one's a tricky one because it's on another sheet of paper. You don't have to write this down, just watch me do it. I don't know. I know that 1 and 6 are factors and 2 and 3 are factors. But because I need these signs to be different, all right, I need the signs to be different. Will 1 minus 6 give me negative 5 or 2 minus 3?
1 minus 6.
Right. So
1
this
minus 6.
2 minus 3 gives me negative 1. And so that doesn't work. And if I were to make both of them negative, I'm no longer getting a negative 6 when I multiply. I get a positive 6. So this one is off just by a little bit, but enough for it to make it wrong. Does that make sense?
Yes.
Yeah, so the sixth one is the trickiest one because you got 1 and 6 that gives you 5 and 2 and 3 that also gives you 5, and you really just got to pay attention with signs past that. So 1 and negative 6 are the numbers that are going to go in my factors. So x plus 1, x minus 6. So I did the slide. What number am I going to divide by?
2.
2.
Yep, 2. So divide by 2. Divide by 2. Divide by 2. All right, and then bottoms up here inside the factor. 2x plus 1. And then 6 divided by 2 gives you 3. All righty. Let's see. Do y'all want to try this one real fast on your own?
Yes.
Try 14 and then I'll show the answer. Okay. So is that what y'all got?
Yes.
Sweet. All right. Down here, watch out for the combination ones. All right, where you could have a GCF and then you also have to factor. That also gets people a lot. So on example 15, you see you have X in all your variables. So before you can start trying to do anything with this one, you do need to take any GCFs out first. So if you take an X out of all these guys, you're left with X squared plus 12X plus 32. And your GCFs, they hang out on the outside. So once you put them out there, they just hang out there. Don't do anything with them. Don't slide, divide, bottoms up, or anything crazy like that. They just hang out on the outside. You can ignore it. And then we can factor this guy. This is an X method. There's nothing in front of the X squared, so it's just a nice regular X method. 32 and 12, which is 8 and 4. Right, yeah. So you get X plus 8, X plus 4. This is a mess up. Sorry. And your GCF is gonna just follow along in front. All right, let's look at this page here. Let me see. I'm just gonna pick out a few and then the rest I'm gonna have y'all try and I'll show you the answers tomorrow, but let's just kind of pick around it. Let's do this first one here. All right, what's the first thing I'm gonna do on this guy? 24x squared minus 8.
Take out an X.
You have an x. Do I have anything else I can take out?
8.
An 8. Very good. So I can take an 8x out. When I take an 8 out of 24, I'm left with 3. An x out of x squared, I'm left with x. Minus, took the 8 and the x out, but I still need that one holding spot. All right, so make sure you have a term there, even if you took it out. All right, then from here, I'm looking at the inside. There's nothing else I can do. There's no exponents. That's a pretty good sign that you're done. That's as far as that one could go. So do make sure you take the greatest common factor. So the biggest thing you take out, the 8 and the x. And if you see one that looks like something you want me to try, let me know. Oh, let's do this one. 2x squared minus 8. What would you say the first step is?
2x squared minus 8. Divide by 2 or take out 2.
Right, take the GCF of a 2 out. You get x squared minus 4. All right, are you done?
It's a difference of squares.
Very good. And so you should recognize the 4 and you're like, that's one of my perfect squares. X squared, also a perfect square. So you can split that up into the two factors. And you see the GCF just follows through. And so x times x gives you x squared. What number times itself gives you 4?
2.
2. So you got
2.
+2 and a -2. All right. Do you want to do another slide and divide?
Sure.
It doesn't matter.
Those. Here, let's try the big number one. 9x
The 9.
plus 30x plus 25. All right, so first of all, you got to check for GCF. All right, can you divide a number out?
No.
No. Almost makes you think it because you're like, oh, 3 could go into 9 and 30, but 3 doesn't go into 25. So I don't think you can divide a number out. So we're going to have to slide and divide. All right, so we are going to slide 9 times 25. 9 times 25, and I get 225. And I know that because I have my phone, not because I'm a math genius or anything. All right, and I want you to add up and get 30. You would not get asked this big of a number question on the non-calculator part. It would probably be on the calculator part if you were, if that, I don't even know, but. All right, so I need to come up with two numbers that multiply to give you 225, but add up to give you 30. So I like to just go through my calculator and I just start dividing numbers. And it's gotta be, it's gotta be numbers that are gonna add up to 30. So like obviously like 1 and 225 is not gonna be your numbers, right? And even probably 5 and whatever would give you 225 because it's too small. So kind of get numbers that you think would add up to give you 30. And in fact, it's going to be 15 and 15. And if you're really good at perfect squares, you might even recognize that 225 is a perfect square.
5 and 25.
Wait, 5 and 25?
Mm-hmm.
5 times 25 is 125. And I need 225. But close. This is a hard one because it's got big numbers. 15 times 15, though, should give you 225. All right, so I'm gonna put in here x plus 15 x plus 15. But remember, I'm not done because this is a slide and divide problem. So what number am I dividing by?
9.
9. So I'm going to divide by 9. Divide by 9.
Mm.
All right. 9 doesn't divide nicely, but it will reduce. What does 15 over 9 reduce to?
5 over 3.
5 over 3.
Yeah, 5 over 3. Not a whole lot of room for this problem. So you do need to reduce before you do the bottoms up. And so now when you bottoms up on this one, the 3 is going to go in front of both of those x's. And so you have 3x plus 5, 3x plus 5, and oops, hello, you can see that. Hold on. And if you notice, I would be okay if you wrote it like that, but also if you wanted to write it as 3x plus 5 squared, I'm good with that too.
All right.
All right, so that was a good one. That had some reducing in it and some big numbers. So I'm not telling you you have to do this whole page, but do it until you start feeling like, okay, I got it, you know. I'll do the whole page and show answers. So whatever ones you do, you can check your answers with me tomorrow. So they're not super hard, you know. If you struggle with the slide and divide, maybe just hit up the slide and divide ones, or I don't know. It's up to you. You know, this is for y'all to practice on.
Yes, ma'am.
So do what you want. But let me see if I can stop this recording here. Come on, what's going on? Oh, no, let me stop recording. Oh, there it goes. And